Hello and welcome to this lesson on converting recurring decimals into fractions. So just as a quick recap of what recurring decimals are, recurring decimals exist when a decimal number repeats forever. So we have three examples of recurring decimals here. In this first example, we have 0.8888 repeating forever. So we say that this is 0.8 reoccurring, and we put a dot above the 8 to signify that that 8 will repeat forever. In this second example, we have 0.2858585, where that 85 pattern will repeat forever, so we have a reoccurring decimal. And an easier way to write this is you write 0.9285 with a dot above the 8 and a dot above the 5 to signify that that 85 pattern will repeat forever, and no dots above the 9 or 2 to show us that that just appears once. Okay, so finally we have, for our third example, 0.248248,248, where the 248 pattern will repeat forever, so we have a recurring decimal. And an easier way to write this is 0.248 with a dot above the 2 and a dot above the 8. We put the dots over the endpoints of the part of the decimal that will repeat forever. This saves us from putting a dot above every single number that will repeat. Okay, so now I'm going to actually tell you how to convert recurring decimals into fractions. We're going to do this on an example basis, and every single one of these questions contain 3 steps. In this first example, we're asked to write 0.8 reoccurring as a fraction. The first step we need to do is write out the equation. And what I mean by this, we just do 0.8 reoccurring, so 0.888 so on, equals x. Okay, and that's just step 1. Step 2, cancel out the reoccurring digits. This step may vary depending on the question, but with enough practice, you'll be able to see what to do every time. In this case, what we need to do is actually times our equation by 10. So we'll have 10x equals 8.888 so on, reoccurring. Now, some of you may see what the next step is. We need to cancel out the reoccurring digits. So what we need to do is take x from both sides of this equation. So on the left hand side, we'll have 10x take x. And on the right hand side, we'll have 8.8 reoccurring take 0.8 reoccurring, which has come from this equation. We're taking x from each side. So on the left hand side, we're going to have 10x take x is 9x. And on the right hand side, we're going to have 8.8 reoccurring take 0.8 reoccurring. And that 0.8 reoccurring decimal is just going to cancel out, and we're just going to end up with 8. Now, step 3, all we need to do is solve for x. So in this case, we divide both sides by 9, and we get x equals 8 over 9, which is equal to this 0.8 reoccurring, which we assigned to x in step 1. So that's the most simple case you could ask for. We're going to go on to some harder cases now, but we're going to be using the exact same 3 steps. Okay, in the second example, we're asked to write 0.85 reoccurring as a fraction. So again, we just write out the equation to start. So x equals 0.85 reoccurring, so 0.8585, so on, so on. Now, step 2. We need to find a way to cancel out the reoccurring digits. If we try the same method as before, timesing both sides by 10, it won't work this time, and I'll show you why it won't work here. So times both sides by 10, we get 10x equals 8.585858, so on. So what's going to happen here is that if we try to take x from both sides, these digits won't cancel out. So we'll get 10x take x on the left hand side, and on the right hand side we'll get 8.58 5, 8, oops, 5, 8, 5, 8, so on, take 0.858585, so on. As you can see, these decimals here are not going to cancel each other out, so we can't do it this way. What we actually need to do in this case is times x by 100. So we know that this won't work. So if we times x by 100, we'll get 100x equals 85.8585 reoccurring. Now, if we minus x from both sides of this equation, we'll get 100x take x on the left hand side, and on the right hand side we'll get 85.8585 reoccurring minus 0.8585 from our equation here. So on the left hand side, we're just going to get 100x take x is 99x, and on the right hand side, 85.85 reoccurring take 0.85 reoccurring, we're going to get 85. Those decimals are going to cancel out. Now all we need to do is solve for x, so divide both sides by 99, we're going to get x equals 85 over 99, which from our question here is just equal to 0.85 reoccurring. So we've written our reoccurring decimal as a fraction, which is 85 over 99. Okay, we have another example here, which is very similar. In step 1, we just need to write out the equation. So x equals 0.248248, so on. And we know that timesing by 10 won't work, and we should be able to see now, using our intuition, that timesing by 100 won't work either, because we won't be able to cancel those decimals out. So in this case, we need to times by 1000 and get 1000x equals 248.248248, so on and so forth, matching up those decimals so we can cancel them out. Matching up the decimals here so we can cancel them out. So taking x from both sides, we get 1000 x take x equals 248.248 reoccurring minus 0.248 reoccurring. Now, on the left hand side, 1000x take x is 999x, and on the right hand side, 248.248248, so on, minus 0.248248, so on, is just 248. Those decimals will cancel out. So all we need to do now is solve for x. Dividing both sides by 999, we get x equals 248 over 999, and this is equal to our 0.248 reoccurring from our question. Okay, so in our final example, it's about as hard as it gets for these questions. We've asked to write down 0.92 and then 49 reoccurring as a fraction. The reason this is difficult is because we have this 2 here inside the decimals, which is not reoccurring. But we're going to be using the exact same steps as before. So our first step, we need to write out the equation. So we have x equals 9.2494949, so on. Now, the trick with these questions is we want to get the decimals to only contain the reoccurring digits. So in this example, we want to get this 2 out from the decimal. And to do that, we times our equation by 10. So we get 10x equals 90 92.4949, so on. And now we need to find a way to match up some decimals so we can cancel out this 49 reoccurring. And how we do this in this case is we times this x equation here by 1000. And we get 1000x equals 9249.4949 reoccurring. And now you might be able to see we can use this 10x and this 1000x to cancel out those reoccurring decimals. So we have 1000x take 10x equals 9,249.49 reoccurring. Take 92.4949, so on. And from this, on the left-hand side, we're going to get 1000x take 10x equals 990x. And on the right-hand side, it's a bit more messy than before, but those decimals are going to cancel out. And if we work out the answer to this, we're just going to get 9,157 on the right-hand side. So, our final step, we just need to solve for x. So, divide both sides by 990. So, this will give us x equals 9,157 all over 990, which is equal to our 9.249 reoccurring from our original equation and our question. So, I hope this enlightens you on the method of how to convert reoccurring decimals to fractions, and with enough practice you'll be able to see this process and what you need to times our x equation by in quite a quick time. If you have any questions, please drop a comment or feel free to email me. Thank you for listening.